Geometric sequences are next, and if you can remember from assignment 1, geometric sequences are when we are multiplying as we go down our line. So all of these in this section are going to be where we're multiplying. As we go from one number to the next, we have to multiply. And remember that if it looks like divide, you have to rewrite it as a multiplication. And you can go ahead and click down in your answers at which one you think is correct. And now what we're going to do is we are going to look at that first sequence right here, the one that I've started marking up, and we're going to see if we can find what we are multiplying by to get to the next number. So 5 times what is going to be 10, and the answer is going to be times 2. 10, will it still work times 2? Yes. And 20 times 2, yes. So every time we're multiplying by 2, so your R value is going to be 2 for that one. If you don't understand, kind of like we did with the arithmetic sequence, you can always do looking at two numbers side by side. Start off with your second number, 10, and remember that when we try to go backwards, when we try to figure something out, we do the opposite. So instead of multiply, you would divide. 10 divided by what? Okay, 10 divided by 5, because that's our first number, gives you 2. And that's how you can get those numbers. You can also do it on the next one, starting with these two values. You would start with your 20, and you would go backwards, doing the opposite of divide. 20 divided by 10 is 2. And you can keep doing that if you need to figure it out if you can't see going forward. So your next answer, you have your R value of 2. If we want to see what a geometric sequence looks like, we're going to do the very same thing that we did. I'm going to erase these bottom values just to keep it a little bit more clear for us. We're going to do the same thing that we did on our arithmetic sequence. We are going to make this a table so that we can go type it in. And remember that our sequence values are always going to go into our Y. The X values talk about where does it stand in this line. So 5 comes first, so you're going to put a 1 above it. Where is the 10 in this line? The 10 is second, because it's the second number of the sequence. The 20 comes third, 1, 2, 3, and the 40 is fourth in line. So we're going to go to Desmos, and we're going to type this in. I'm going to use the table that I already had, and I'm going to type in my values: 5, 10, 20, and 40. Okay, so now we're going to look at our values, and it's a little bit harder to see on this one. You can see that it does do a little bit of a curve so that you know it is not linear. So now it's between quadratic and exponential. Well, what I would like to do is I would like to show you going backwards a little bit. Let's see if we can do a 0. So if we go backwards a little bit more, what would I multiply by 2 to get 5? That would be 2.5. Oh, that is not 2.5. So that would be 0 is 2.5. And I don't know if you can start to see it there, but then I think what's really going to do it for us is if we have a -1, if we go back one more spot. So what you would need to do for that one is you would need to 2.5 divided by 2 to go backwards one more, and that would give you 1.25. All right, now you can see, is it going to be quadratic or exponential? And basically at this point, hopefully you can start to see that it would be exponential. Maybe as we go on, you'll be able to see the pattern a little bit more. So we have arithmetic is linear, and all of our geometric sequences are going to be exponential. So again, right here, the worksheet that we were going to do in class had your X and your Y, 5, 10, 20, and 40 go here, and then we have our 1, 2, 3, and 4. And as we graph those, that is going to be, and you can also maybe see it if you went up on the other side and added another one, 5, that would be an 80, and you would see that that does start to go really high really quick.